We're on the last section, 2B.6, verifying inverses. So I feel like for the most part, we're pretty confident with graphically, but we're going to just kind of reiterate graphically, okay? Because there are two ways to identify whether inverses, if two functions are inverses of each other, graphically and algebraically. We kind of lump table with graph, right? Because usually a table is going to lead to graph. All right. So for example here, if you look right here on your notes, we have this graph already drawn for us, right? And this graph has two functions. You have function f of x, and f of x is made up of tables. Uh-oh, sorry. All right, we have f of x here, and f of x is made up of these points, right? We have negative 1, 1, 0, 5, 3, 7, 7, 8, right? And then we have the inverse. Well, we're trying to see if it's the inverse. And the inverse is made up of 1, negative 1, 5, 0, 7, 3, 8, 7. Graphically, we can tell that these are inverses because they are reflected over the what? They're symmetrical over the, what is this called? Y equals X. So we see that symmetry. So they're symmetrical over the Y equals X. Usually when there's symmetry, they're more than, if they're going to intersect, they're going to intersect on that reflection point. Okay. And notice that they are intersecting. Table-wise, we're looking and seeing how the points are switched. Are all of our X's and Y's swapped? It has to be all, not just some. Every single one have to switch roles and do all of them switch roles. Yes. So therefore, we have proven that these are inverse models, inverse relations. Make sense? Yeah. Okay. So we're going to go over this, but we're going to go over it kind of emphasizing the use of technology for it. So on example number 2, we're going to be using Desmos. We're going to go through, graph the lines, pull the table and everything from Desmos. Is that all right? All right. So I'm going to come down here, look over. Anyone still needs this before I move on? Are we good? All right. So in Desmos, we're going to graph these two functions. We're going to graph them in Desmos. But beforehand, honestly, do we need Desmos to graph them? No, because we're geniuses and we know how to graph linear equations. So without Desmos, you should be able to graph these linear equations. So I'm going to graph f of x. F of x is 1/3 x. So that means I begin at 2. This is my b. And then my slope is going to rise 1 and run 3. So I go to positive 2. I rise 1, run 3, rise 1, 3, rise 1. And I'm going to reverse it and fall and crawl. Fall and crawl. Fall and crawl. And then your teacher's going to do her very best to connect these dots in the straightest line you've ever seen. Okay. And that is my f of x. All right. Now we're going to do the same thing for g of x. Again, we are going to begin this time at -2. Our slope is 3. So I go to -2, 1, 2. This time I rise 3 and I run 1. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Is it okay with the pace I'm going for graphing the linear equations? I feel like we're all on the same page and we're able to do it without each other. And then I'm going to, again, concentrate real hard. Yep, that got a little wobbly. Okay, close enough. I know you see the vision. And that is g of x. Looking at these two graphs, are they inverses? Yeah. No. If you look on your y equals x line, So y equals x are the points where 1, 1, 2, 2, 3, 3, 4, 4.
Oh, no.
No. Are they symmetrical around that line? No, they're not. So therefore, f of x and g of x are what? Not inverses. F of x and g of x are not inverses. Okay? And that's because they lack symmetry along the y equals x, right? No y equals x symmetry. Okay? What we're going to use our calculator to do is to analyze their tables and go from there. But just to reiterate, if I had a hard time figuring that out, I could then go to the calculator and graph. So I'm going to graph. There's my y equals x. I'm going to go ahead and put in y equals 1/3 x plus 2. And I'm going to put in y equals 3x minus 2. I don't like that they made this line. Can you not change the color? Just going to hide that one. So now that I have them, remember to look at the table. How do I open the table on Desmos? And the little gear, right? Click on the gear, and it's going to open your table. That's how you open the function table. Not create a table. How do you open a table that already is created? Okay, the reason why I wanted us to look at this one is because notice that our numbers aren't friendly, right? So what I notice here is I'm dividing by 3. If I'm dividing by 3, I want multiples of 3, right? -2 is not a multiple of 3, but -6 is. And -3 is. So when I put in friendlier numbers, notice that it gives me more manageable numbers, right? So this is the simplified table for 1/3 x plus 2. Now, if I wanted to check the table here to double prove that they are not inverses of each other, that means that on the second table, my x values would be the y values from the first table, right? Because inverse means your x and y values switch places. So my x values would be the y values, which are 0, 1, 2, 3, and 4. So when I come and type those in, 0, 0, 1, 2, 3, and 4. Notice that those two values aren't the same, are they? They are not simply just switching the x and the y. So even if you had a hard time visually seeing it, you can look at the table values and see that these are not just easily swapped, right? My x's and y's did not switch places, which means that, again, these are definitely not inverses of each other. Okay? So if you have a hard time looking at it from the graph, don't forget you can always pull up a table and compare the x's and y's from the table. All right, how do we feel about technology, graphs, and tables? Doable? All right, let's do my favorite part. Okay, so on the back, oh, don't look though. You see nothing. Go back, go back. Put it in reverse. All right, you saw nothing a minute ago. I don't know what was happening. So now we're going to talk about how do you solve algebraically, okay? We've already kind of drilled in tables and graphs, but there's also an algebraic method of solving. Solving algebraically means that you are composing. Do we remember composing? Composing functions means you're putting a function inside of a function. You're composing. Composition. Okay? When you are checking for whether two functions are inverses of each other, you have to do two checks. I like to call it the left-hand check and the right-hand check, okay? So we're going to divide our paper in half. On the left side, we're going to do the first composition. The first composition is f composed of g of x. F composed of g of x means I'm taking the entire g of x function and plugging it into f of x for x, right? So it becomes f composed of 1/2 x minus 2. So wherever there is an x, it now becomes 1/2 x minus 2. So we get 2 parentheses 1/2 x minus 2 plus 4. So again, I replace all my x's with 1/2 x minus 2 because that's what g of x equals. You see that? Okay. Now we just simplify. So to simplify, we distribute. What is half of 2? 1. What is 2 times negative 2? And then we're going to bring down what we already had, which is the plus 4. Negative 4 plus 4 is 0, and we're just left with x. That's what we want to happen. We want that to happen on the left and on the right side. If it doesn't happen on both sides, that means that they are not inverses. And that's because not at every point does your x and y roles switch places, okay? So now we're going to do the right-hand side. The right-hand side is g composed of f of x, which means now we are substituting in f of x, and f of x equals 2x plus 4. So g composed of 2x plus 4. So where the x is in g of x, it now is going to become 2x plus 4. So we have 1/2 2x plus 4 minus 2. Okay, so we had f of x, we had 2x plus 4, and we replaced our x with 2x plus 4. And now we're just going to simplify. Okay, pointer and pin. So we're going to distribute what is half of 2, 1x. What is half of 4? 2. And we're going to bring down what was outside, which is a minus 2. And what happens? Cancel each other out, and we're left with x. So what this means is that they're inverses. That means that g of x and f of x are inverses. Okay? How do you feel about algebra? It didn't bother me. It's soothing.
I like this part is the graph because it's just really just putting things.
Yeah. And if it works, then good. If it doesn't, then you're not. You don't see it? All right, let's try it with a log function, okay? An exponential. So again, we're going to do a left hand and right hand check. Draw a little line. Okay, right hand, we're doing f composed of g of x. So f composed, I mean left hand, I'm sorry, of g of x equals f composed of log base 2 x minus 1. That means my power is now becoming a log. Do we see that? So that's going to be 2 log base 2 of x minus 1 plus 1. So again, here's my x. I'm substituting it with g of x. G of x equals log base 2 of x minus 1. So x is now log base 2 of x minus 1. Okay, Remembering our log properties, when you have an exponential and a log of the same base, what do? They cancel each other out. So then our power is set free, and we're left with x minus 1 plus 1. Negative 1 and positive 1 make 0. So our answer is x. So our left hand works. Okay, we're going to do our right hand, which is g composed of f of x, which equals g composed of 2 to the x plus 1. So I'm replacing the x with 2 to the x. So we have log base 2 of 2 to the x plus 1. And don't forget there's already a minus 1 there. And now you simplify. So what I substituted in, I'm going to highlight for you again. So we're replacing x with f of x. F of x equals 2x plus 1. So where x used to be, it became 2x plus 1. And that negative 1 was already there, right? Okay. And what happens here? Those cancel out, and we're left with log base 2 of 2 to the x. And what happens when you have a log and an exponent of the same base? They cancel each other out, and we're just left with x. I always think about this as, have you ever played Mario Land? When he has to like go around, he gets the mushroom, and he gets big, or he hits one, and he, okay, that's my error. Let it be my error, okay? Huh? And he gets little if he gets knocked down, right? Exactly. So this is like a superpower. Ooh, I'm set free. Now I'm big again. Okay. That's what it makes me think of. So since they both equal x, what does that mean about f of x and g of x? They are inverses of each other. F of x and g of x are inverses. And that is how you prove algebraically. Okay. Your class practice for today, it should take you the rest of the class period, roughly 15 minutes. It is 7 questions testing your log properties, okay? I know. So if you come over here, back to our homepage, you'll see it says, what are we doing Friday? Scroll, scroll, scroll. We've already did our do now. We've already did our notes. And now it says class practice and review, exponential and logs. Okay, you're going to do the work for it if you need to show any work on page 84 of your notebook. Friendly reminder over the weekend, make sure you complete your 2B 4 through 6 assignment, graphs of inverses. Okay, start making your note card for your test next Wednesday. We will have our last quiz of the 6 weeks on Monday over 2B 4 through 6. And then notebooks are due when? The 13th, Thursday, because you guys do not have school on Friday, okay? So remember, scroll to the bottom if you need to. Make sure your notebook is in order because your notebook is meant to be an easy assessment grade, not a hard assessment, because you should have been taking your notes all along, right? Because it's a tool meant to help you. All right, are there any questions about what you should be doing for the rest of the period?